Problem 8.23, expand in power series the following functions, specifying the domain of validity of those expressions. So it's expansion, sorry. Okay, so the first one is the sine squared. So you can try and compute, you have the expansion for the sine, you can compute the square of that, trying to multiply different terms. But an easier way to do that is actually to use this trigonometric identity. The sine squared is 1 minus the cosine of 2x divided by 2. Okay, you get this using the formula for the cosine of 2x. Cosine of 2x is cosine squared minus sine squared, and you have 1 is the cosine squared plus the sine squared. So if you subtract this first expression from the other one, you have 1 minus the cosine of 2x, you have 2 times the sine squared, right? So that's where that comes from. Now we know the expansion for the cosine, right? The cosine is 2x, sorry, this is 1 minus 2x plus 2x, sorry, minus 2x squared divided by 2 plus 2x to the 4th divided by 4 minus 2x to the 6th divided by 6, sorry, this is not 2, sorry, 2, this is 4 factorial, 6 factorial, and in general you have minus 1 to the n, sorry, to the n, let's see, this is to the n plus 1, yes, times x, well in this case is 2x to the 2n, yes, that's the series expansion, divided by 2n factorial, right? So this is 1 minus that, you get so this is 1 minus 1 to the n, 0 to sorry, so this is minus 1 to the n only. Okay, yes, this is the series, right? You can write it like this: the sum from n equals 0 to infinity of minus 1 to the n 2x to the 2n divided by 2n factorial. Okay, yes, so this is 0, that's good. Now 1 minus that, so it's 1 half minus this divided by 2, so this is the sum from n equals 0 to infinity of minus 1 to the n divided by 2x to the n divided by 2 times 2n factorial. And so this is the same, but the first term goes away, 1 minus 1. So this is just the sum from n equals 1 to infinity of, and then this is minus times minus 1 minus n minus 1 to the n plus 1 times 2 to the 2n x to the 2n divided by 2n factorial, and then 1/2 goes out if you want. Okay, this is the expression, and the convergence of this is the whole real line, because the convergence of the cosine, we have seen that it's in the whole real line, so this is just a combination of that. So the convergence is in real line. Okay, the domain of validity of this expression is the whole real line. Okay, now let's go for the second is f of x is the logarithm of the square root of 1 plus x divided by 1 minus x. And if you use the properties of the logarithm, you'll see that this is 1/2 of the logarithm of 1 plus x minus 1/2 of the logarithm of 1 minus x, right? Now we know that the logarithm of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x4 over 4, blah blah blah, and in general it's minus 1 to the n times x to the n divided by n, right? When n is from 0 to infinity, right? Sorry, well, maybe minus 1 to the n plus 1, yes. And then the logarithm of 1 minus x is minus x squared over 2 minus x cubed over 3 minus x4 over 4 in general. So this is minus x to the n over n, right? If you take common factor here 1/2, right, and this is just the logarithm of 1 plus x minus this, so we subtract this, this is just plus everything, so the logarithm of 1 plus x divided by 1 minus x is equal to 2x, right? And then this goes away, and then we have 2 times let's see, is x cubed divided by 3, this goes away, and so forth and so forth. So this is, if n is odd, this is 2 times, and sum of x to the 2n plus 1 divided by 2n plus 1. But now this is divided by 1/2, so the sum of this is the sum from n equals 0 to infinity of x to the 2n plus 1 divided by 2n plus 1. This is the sum. Okay. Now, what's the domain of validity of this? If you compute the radius of convergence of this, the root test of this, you are always obviously going to get the absolute value of x has to be smaller than 1, right? Because this is the nth root of this, right? So this is the absolute value of x has to be smaller. If x is equal to 1, this is not defined, okay? Okay, and let's see, we have 3 f is x plus divided by a plus bx, and here the trick always with these things is to write everything as if it was a geometric series, right? So first we have x times 1 over a plus bx, and now we want to write this as 1 over 1 minus something. So this is x, and then we have take common factor a here. So this is 1 divided by 1 plus b over a times x. And or in other words, we can write this like this. 1 minus, and then we have minus b over a times x, right? So this is x over a, the sum from n equals 0 to infinity of minus 1 to the n b over a x to the n. Okay. Now if we expand this, or apply this, this is the sum from n equals 0 to infinity of minus 1 to the n b to the n x to the n plus 1 divided by n a to the n plus 1. This is the sum. Or you could write it from n equals 1 if you want. This is the sum from n equals 1, and this is minus 1 and minus 1 b to the n minus 1 divided by a to the n times x to the n. If you want to write it as a proper power series, right? Now if you compute the root test for the absolute convergence of this, this is the limit when n goes to infinity of the nth root of this, the absolute value of this is bn minus 1 an xn. So this, the absolute value of all of this is, of the nth root of this is b over a times x. This has to be smaller than 1. That means that the absolute value of x has to be smaller than a divided by b. Okay, that's the idea. Okay, so we have the absolute value of x has to be smaller than a divided by b. Okay. Okay. Now we have for part 4, f of x is 1 divided by 2 minus x squared, and again we want to write this as a geometric series again. So this is 1/2 times 1 divided by 1 minus x squared over 2. So this is 1/2 of this sum from n equals 0 to infinity of x to the 2n divided by 2 to the n, right? And so getting the 2 inside, we have n equals 0. This is x to the 2n divided by 2 to the n plus 1. And you compute the convergence of this, you get that the root test says that x squared over 2 has to be smaller than 1, and this implies that the absolute value of x has to be smaller than 2. Sorry, that the square root of 2. Yeah. So the absolute value of x has to be smaller than the square root of 2. That's the convergence of that. And let's have the last one. Part 5 is 1 plus x minus 1 minus x e to the 2x divided by e to the x. Okay, so let's see. We can separate this in two fractions actually. This is 1 plus x divided by e to the x minus, and then we have 1 minus x times e to the x, right? But we can rewrite this again as 1 plus x e to the minus x minus 1 minus x e to the x, right? And now we have 1 plus x and the sum from n equals 0 to infinity of minus 1 to the n x to the n divided by n factorial minus, and then we have 1 minus x, the sum from n equals 0 to infinity x to the n factorial, right? So let me write this different sums. We have the sum from n equals 0 to infinity of minus 1 to the n x to the n factorial plus the sum from n equals 0 to infinity of minus 1 to the n x to the n plus 1 divided by n factorial minus the sum from n equals 0 to infinity of x to the n factorial plus the sum from n equals 0 to infinity of x to the n plus 1 over n factorial. Okay, now how to deal with these things, right? Maybe it's easier if we just expand this thing. So this is going to be 1 minus x plus x squared over 2 minus x cubed over 3 factorial plus x to the 4th over 4 factorial, blah blah blah, right? Then we have this sum, which is plus, and we have let's see, this is x minus x squared plus x cubed over 2 minus x cubed over 3 factorial plus blah blah blah. This is the typical minus 1 minus x squared over 2 minus x cubed over 3 minus x fourth over 4 factorial plus blah blah. And then this is the last one is plus 1. Let's see, plus 1. Plus x. We have plus x squared plus x cubed over 2 plus x to the 4th over 3 factorial plus and so on and so forth, right? So it's obvious that the terms here, this go away, this goes away, and then we have what? This and this goes away, this and this goes away, and again this and this go away, this and this go away. So all the even terms go away. You can see this, and then here what we have is the sum from n equals 0 to infinity of what is this, x to the 2n plus 1 divided by 2n, right? Is this 2n? Yes, so this is the previous element, minus, wait a minute, this is 1 over 2n factorial minus 1 over 2n plus 1 factorial, right? Times 2, right? Because this is 2 times 1 over 3 factorial, 2 times 1 over 2 factorial minus 2 times over 3 factorial, right? This is this sum. And now we can operate with this. This is, in order to get this 2n factorial, you get 2n plus 1 divided by 2n plus 1 factorial. This is minus 1, right? So you get 1 and 1 get cancel out, and you multiply by 2 here, right? This is 2, so you get 4n divided by 2n plus 1 factorial. So the final sum of this is the sum from n equals 0 to infinity of 4n. It's not from n equals 0, right? Because it's from n equals 1. From n equals 1. Because these two guys go away. From n equals 1 to infinity of 2n plus 1 factorial x to the 2n plus 1. This is the series, the final series, and the radius of convergence is going to be infinity, the whole real line. This expression is valid for the whole real line, as we have seen for the exponential in general.